Problem number 10. A figure shows a very large non-conducting sheet that has a uniform surface charge density sigma equal to -2 microcoulomb per meter square. It also shows the particle of charge q, which is equal to 8 microcoulomb at a distance d from the sheet. Both are fixed in place if d is equal to 0.2 meter. At what positive and negative coordinate on the x-axis is the net electric field of the sheet and particle is 0. And the third question is, if d value is changed to 0.95 meter, what coordinate on the x-axis is the net electric field is equal to 0. So let's see the figure. What is given in the figure? You have a thin non-conducting sheet. So that means here the sigma, they mentioned sigma value here. So this is the non-conducting sheets. And the surface charge density on this non-conducting sheet is -2 microcoulomb. And also you have a point charge, which is the red color dot, Q value, which is 8 microcoulomb. The distance between this sheet as well as the charge is d, which is equal to 0.2 meter. And now what we are going to do, we are going to find the positive and the negative coordinate on the x-axis where the net electric field should be equal to 0 by this thin sheet as well as the charge. So for that, we have to identify the electric field value. So let's first find the direction of the electric field, and we have to identify where the net electric field should be equal to 0. So let's see this diagram. We have three locations. So location 1, and the location is between the sheet as well as the charge, and the location 3rd is next to the charge. And you can see this line is the x-axis coordinate, and we are going to fix the positive value as well as the negative value on this x coordinate, and we have to find, after you fix that value on this x coordinate, you have to find the value of the net electric field on that region should be equal to 0. Clear? So for that, first we have to identify what is the net electric field in location 1. So you can see this is a non-conducting sheet. They clearly mentioned this value is -2 microcoulomb per meter square. So that means you have the negative charge on this plate, and this is the positive charge, which is the point charge. So if you have the negative charge distribution, all the field lines are inward direction. So that means the field lines will be inward direction based on this sheet charge. Based on this positive charge, your field lines are outward direction. Now you can see these two arrows are opposite each other. So what is the net electric field here? The net electric field in this location 1, which is equal to 0. Likewise, we have to find the same thing in the midpoint of the middle. That means the between the sheet as well as the charge. So based on this negative charge, the field lines are inward. And based on the positive charge, the field lines are outwards. That means it will be like this. That means here your net electric field is not equal to 0 because both arrows are in the same direction. When you come to the third location, based on this negative charge, the field lines are inward. Based on the positive charge, the field lines are outward. So here also the net electric field is equal to 0. So now what we have to do, we have to fix the positive value and the negative value on the x-axis, and you have to identify that point is in the region of net electric field should be equal to 0. If it is not, then you have to give the answer. Now we are going to apply the rule for the non-conducting sheet. The electric field due to non-conducting sheet, which is equal to sigma over 2 epsilon naught, and this sigma is the negative charge distribution, so better we can take the magnitude value. Likewise, the electric field due to the point charge q, which is given by the rule E equal to k q over r square. Now you can see these two equations. The left hand side of the equations are same, so we can equate the right hand side. So by that, sigma over 2 epsilon naught, which is equal to k q over r square. Now I am going to rearrange this equation in terms of r square. Therefore, r square, which is equal to k q 2 epsilon naught over sigma. and therefore R, which is equal to square root of K Q 2 epsilon naught over sigma value. Now I'm going to substitute the value here, and we have to find what is the value for R. And after we find, we are going to fix that value in this figure. So the value of K here is 8.99 multiplied 10 to the power of 9, which is the Coulomb constant, 10 power 9. And the charge value is 8 microcoulomb. So 8 multiplied 10 to the power of minus 6, and then multiply by 2, which is this one, and then the epsilon naught value is 8.85 multiply 10 power minus 12 over the surface charge density is given here as minus 2. I'm going to take only the magnitude, so 2 microcoulomb per meter square. So 2 multiply 10 to the power of minus 6. So let's see what is the value of R. So square root of 8.99 10 to the power of 9 multiply 8 multiply 10 to the power of minus 6 multiplied by 2 multiplied by 8.85 10 to the power of minus 12 over 2 multiply 10 to the power of minus 6. What happened? Again I have to do, so 8.99 10 to the power of 9 multiplied by 8 10 to the power of minus 6, 2 multiplied by 8.85 10 to the power of minus 12 over 2 multiplied 10 to the power of minus 6. I got the answer here as 0.797, which is meter. And after you take the square root, this is positive as well as negative, plus or minus 0.797. That means R takes the value of plus 0.797 meter minus 0.797 meter. Now what I am going to do, I am going to fix this value on this diagram. And also they clearly mention the distance between this charge, point charge, as well as the surface charge density of the non-conducting sheet is mentioned here as D, which is equal to 0.2 meter. Now after you fix this point, you have to identify whether that point is in the net field equal to 0 or not. So let's take the first value. So if you place this value on this x-axis, and from the sheet you can see this distance is 0.2. So if you fix, this point will approximately come next to the point charge. Am I right or not? Next to the point charge. Am I right? So that means when you fix R equal to plus value of 0.797 meter, this value, the electric field is equal to 0. That means we can consider this point. Likewise, you have to fix this negative charge. So from this sheet, if you see, your negative value will be here. So in this location also, your net electric field is equal to 0. So that means R equal to minus 0.797 meter is also considered, because both places your net electric field is 0. That's the reason they ask in the question, you have to fix the positive and the negative coordinate on the x-axis, where the net electric field by the sheet and the particle should be equal to 0. So you can see when we fix the positive value and the negative value, your net electric field on this location is 0. That means two values are considered. But when you come to the third question, now we change the distance to 0.95 meter. That means you can see this diagram. Now the value of D here is 0.950 meter. So now we are going to fix the value R equal to plus 0.797 meter and R, which is equal to minus 0.797 meter in this axis. And before that, we have to write in this left hand side, your net electric field is 0, but also here the net electric field equals 0, but in between your net electric field is not equal to 0. So let's fix this point. So now you can see 0.797. 0.97790 is when you fix, it is in the place of net electric field is equal to 0. So R equal to plus 0.797 797 will not be considerable. Why? Because the net electric field on this location is not equal to 0. So it's not satisfied, right? The condition is not satisfied. But when you fix this negative value, it is here approximately the value of negative value of R is here. So minus 0.797 meter. So it is in the place of net electric field. So we can consider the negative value. So this is the answer for this question. The most important thing, you have to find the net electric field where it is 0, where it is not equal to 0. That's very, very important. Based on that only we can find the answer here. Clear? So this is the answer for this question. That's it. Thank you.